Hello everyone, I am Manav, and in this video we are going to learn about energy and power. As in my previous video I told you about work done, some of the cases, some of the conditions and criteria for any action to be counted in work done of physics. And the video before that, my previous video, that was on formula of class 11th work done. And what was that formula? Work done is equal to F multiplied by S multiplied by cos theta. In this video, I'm not going to continue with that particular formula. Basically, I'm not going to focus on that thing. Why? Because that topic relates with work done. But in this video, we are going to learn about energy and power, about the formula of energy and power, and also law of conservation of energy. How? Basically, energy is transferred from one form to another. And I'm not going to dance. So, if I continue with this topic, first I would like to tell you about a little simple definition, a bit simple definition of energy. So what is energy? A person doing too much work, we say he has energy. He has energy. A man cannot do work really well, we say he does not. Or he don't have any energy. Yeah, is it right? Absolutely. So from this, what we can conclude, that energy is the capacity to do work. Is the capacity to do work. How much capacity, how much ability you have to do work. The ability, the capacity to do work is known as energy. And in our syllabus, we only have two energy. There are light energy, heat energy, nuclear energy, any other heat energy, and the two left that we are going to study in this video are potential energy and kinetic energy. There are many energies: heat energy, light energy, potential energy, kinetic energy, nuclear energy, many. An atom and a nucleus of atom. Now you will say, what do you mean by nucleus? Is it right? What is nucleus? What? Nucleus. Nucleus is nothing but a subatomic part of an atom at the center of an atom. And in a nucleus, there are only two things: proton and neutron. Neutron are zero. They have zero charge. They are neither positively charged nor negatively charged. Is it right? Absolutely. There was another thing. Whole nucleus is zero. It has zero charge. I think is it due to the magnitude. I mean, the magnitude is same. That's why it is so. I'll just leave that thing. Leaving that thing, if I continue with my topic, that is energy. So now we get a simple definition of energy. What is the simple definition? That simple definition is capacity to do work is known as energy. Ability, capacity, whatever. Now in our syllabus, there are two types of energy. Two types. Kinetic energy and potential energy. Now when I was saying that there are two types of energy, I got a word, kinematics. If I talk about kinetic energy, I'm going to tell you about kinetic energy. But whenever I say this word kinematics, what is kinematics? Kinematics is nothing but it is a branch of physics that deals with motion, that deals with the motion. In kinematics, you learn about displacement, distance, three equation of motion. Any other thing left? Any other thing that is left? Velocity, average velocity, speed, average speed, acceleration, momentum. I think not momentum. Three laws of motion. Everything that deals with motion is equals to kinematics in physics. Yes. You know there are three equation of motion. Kinematics. It's of kinematics. First equation is V is equal to U plus AT. V is equal to U plus AT. There are three equations of motion, and these three equations have helped me too much as while solving any numerical. As whenever there are some of the variables meant to find displacement, height, its displacement, velocity, initial velocity, final velocity, time. So these equations help me a lot. Yes. So I think you should also know about these equations. First equation is V is equal to U plus AT. Second is S, mean displacement, is equal to I think U plus half AT square. It is just at the last. I know it is half AT square, and at the first I think I'm not getting that. And the third equation, it is too much simple. That is 2AS is equal to V square minus U square. Mean 2 multiplied by acceleration multiplied by displacement is equal to initial. square of final velocity and minus square of final velocity minus by initial velocity का square. This is what kinematics. But I'm not going to tell you about kinematics. I am making this video to tell you about kinetic energy, potential energy and power. So let's again, I forgot the track, so let's again come to our track. Let's again come to our aim to achieve today in this video, that is to understand about kinetic energy and initial potential energy and also about the power. So kinetic energy is equal to motion. Now understand this thing. Till now I have not told you about the particular definition of this thing, of this kinetic energy, but I can say, or you can also say that thing, this kinetic energy, in the definition of kinetic energy there will be concern of motion, and this is fully proved because kinetic energy is the energy possessed by any object with the help of its motion. If there is too much speed is higher. If speed is higher, so then kinetic energy will be also more. So my kinetic energy and speed motion is directly proportional. Proof. So what is kinetic energy? The energy posed by any object with the help of its motion. बहुत सही. A car moving had obtained any kinetic energy. Is it? Absolutely. I am moving. Whenever I already told to you that whenever any object is in motion, it possesses kinetic energy. Now let's move to derivation of the formula of kinetic energy. That is, kinetic energy is equal to half mv square. What? Kinetic energy is equal to half mass multiplied by velocity का square. Let's take an example of a man of 20 kg. 20 kg, not of man, it's not a man, a children. Let's suppose a children of 20 kg with a velocity of 400 centimeter second. Centimeter 400 no, not 400. We will take smaller unit. 4 centimeter second. 4 centimeter second. 4 centimeter second. Please remember one thing, that SI unit of velocity is meter per second. It is in centimeter, so we don't like this thing. Whenever any object is in it's a CGS unit, MKS unit, at that time you will have to change it in SI unit in physics. If you will not do that, so your marks will be deducted. Please remember this. So, for your marks, for the concern of your marks, you must be aware how to change unit from centimeter to meter, hectometer to meter, everything. As you all know, that centimeter is CGS unit of distance. So 4 centimeter square, 4 centimeter second. Now I'll change. Whenever we change a smaller unit to a larger unit, what we do? We do nothing but we will change it into decimal. Should we change? Or should we change the answer that we will get? Let's do experiment that we will get. I know that we will get the same answer, but for the confirmation, let's do it. First, let's take 4 centimeter. Yes, sir. They have given this, so we will also give the half multiplied by 20 multiplied by 4 multiplied by 4. 20 become 10. I just cut it 10. I also have the power. I also have the basically ability to change 4 or to cut 4 here, but I changed it. That's my choice. 4 multiply 4, 16. 16 multiplied by 10, 160. What we have find out? Kinetic energy. The SI unit is joule. 140 joule. 160 joule. Change it, divide it with 100, because 1 centimeter is equal to 100 meter. Wait a second. 1 meter is equal to 100 centimeters. Sorry, I said opposite to this. So 160 divided by 100. 0 to 0 cut. I think we will get 1.6, 1.6 as answer. 1.6 joule. If we are going with SI unit. And in the first step, if I change that 4 into 100 means 0.04. 0.04 multiplied by 0.04. I don't have copy or pen so that I can do. That's why I'm leaving it. You can do it. So let's, as we get the formula, also as we understand as we have understood the theory. So why we are waiting? Let's move to our next topic, that is potential energy. What is potential energy? What is potential energy? A big question mark. First thing, potential energy is equal to stored energy. It is the energy that is stored in an object. Oh, object. There is object. Let's suppose this here, and I took it here. Before I take it, gravitational force acted on it. G, acceleration due to gravity. Gravity. Gravitational force acted. Due to of that thing, the work is done against gravitational force, and that force stored in it, and the force that stored due to the height is equal to potential energy. What? It is equal to potential energy. This is what potential energy. It can be. It can also be stored with the help of compressing it. After this, formula of potential energy is M multiplied by mgh. M multiplied by acceleration, mass multiplied by acceleration due to gravity multiplied by height. is equal to potential energy. And what is the SI unit of potential energy? SI unit of potential energy is also joule. जय हो. चलो ठीक है भाई. Potential we have done potential and kinetic. Now let's move to our last topic. I'm not going to cover I'll going to cover power and law of conservation of energy. We have learnt about law of conservation of mass in chemistry. In the 3rd chapter of class 9 I learnt it. But this is law of conservation of energy. What is law of conservation of energy? Or particularly yes, energy can neither be created nor be destroyed. It can only be transferred from one to another. Yes, this is just a line, but a proper answer for this question, for this particular basically this theory. What is this theory? Is the answer of this theory is what law of conservation of energy tells to us. It tells that sum of kinetic and potential energy will always be equal. It will always be what constant. There is object at height. Kinetic energy is 0. Why? Velocity is 0. Why? Because it is not moving. But it is at height. So there is potential energy. Potential energy is, let's suppose, 2000 joule. At midpoint, my height decreased, but it gained some velocity acceleration because it is acceleration due to gravity. So at half, it will always be 20,000. So my kinetic energy will be 10,000 and my potential energy will be 10,000. And at the 0 point, there is no height. So potential energy is 0. And for the constant, to make it still constant, kinetic energy will become absolutely true. It will become 20,000 joule. After this, power. A man doing work in very less time. A man doing work in a very too much time tells us power. He have power, or he has power, or he has not power. 0 power. 0 watt. SI unit of power is watt. W. So